In this video, we're going to talk about angles, both the notation and how to measure them. So we can describe the measurements with certain vocabulary. We can also find measurements with certain vocabulary. And then we'll also look at using a protractor and how to actually measure the angles. With that, if you don't have a protractor, that is absolutely okay. At no point am I going to have you measure anything with a protractor, but just in case down the line you come across one, need to measure an angle, you'll know how to do it. So first off, let's get a definition for angles. Now, it's a combination of 3 points. So let's say I have these points A, B, and C here. A, B, and C. Now, there's going to be 2 points here, and then one point's going to have the specific name of vertex, which will kind of be the middle point of our angle. So let's say we call B the vertex. What that would mean is that that's going to be kind of the starting point. So what I'd imagine is that I'd start a line at B, and it would go through, let's say, point A, and another line would also start at point B and go through line C. So when we do that, when we focus at the vertex, which makes this point of the angle, it's going to be the measurement between those 2 lines. So this measurement right here would be an angle measurement. So for a definition, what we'll say is for angles, it's a measurement between 2 points and a vertex. Now, for notation, there's a few different ways that we could write this angle measurement. So if I'm trying to describe this color blue here, this blue measurement here, the symbol we'd use looks like this. That would be read out loud as angle. And then we can do it as a combination of 3 letters, and the order doesn't really matter, but what is important is that B would be in the middle. So I could describe it as angle ABC. And by describing it that way, it gives me the order to follow. So it's angle, and we're starting at A, going to B, and then ending at C. So with that, I could see how that measurement comes through. We could also describe this as angle CBA, and it would give us that same measurement. Starting at C, going to B, and then going from B to A would get us that same point. But just notice if I changed things, so as a little side note here, if I had those 3 points, A, B, and C, and I wanted to talk about, say, angle measurement CAB, what that would mean is I would have to go C to A, and A would end up being my vertex. So I go C to A and then A to B. So with that, the angle that would be described there would actually be this angle being formed at A. So it wouldn't connect at all to this previous picture that we just drew. It would be doing something completely different. So the order of the letters is important. More specifically, that middle letter has to be the vertex. Another thing we can do is just call it angle B, because that's really where the angle is occurring. So just saying the angle and then whatever the vertex is, since those other letters, the order isn't mattering so much, we can just rely on that vertex. So with that, let's talk about actually getting a numerical measurement for our angles. And to do that, we often use a protractor for measurement. It's kind of our ruler for angles. Now, when you have a protractor, what you want to do is line up the vertex right here in the middle of it. So you'd put the vertex right there, and then it just kind of depends. Maybe your line segment's going off to the right, or it could be going off to the left. Either way, this protractor is going to do this same measurements. So let's say it's similar to the picture we did up above there, and it's going off to the right here. What you could see is that there's 2 numbers being listed here. There's 0 and 180. In our case, this is our starting point. So where we're starting is at 0 degrees. So we're at 0 degrees here, and then we want to draw our second line and where it's landing. And what happens is, say I have my second line here, I'm going to do a little activity. It starts at 0 degrees, and then as I move up, it's gaining angle measurement. So say I'm right here, it's this kind of middle point, and it's between 0 and 10, so right there would be 5 degrees. And then if I went, this would be 20 degrees, 30 degrees, 40 degrees, so on and so forth. And you could even get more exact, like, so let's say I landed right here, that would be 0 to 50, and then it has one little extra increment. So that measurement right there would be 51 degrees for this angle measurement here. If we kept going with it, let's say I kept going, up here, this is a special angle that we'll talk about where we land right at 90 degrees. Oops. That's going to give us something that's called a right angle. Sorry, I had a little glitch there. So 90 degrees, it's this middle point for when you can see where a protractor begins and then ends, and it's this middle point would be 90 degrees. And then when we get to over here, let's say I landed here where it looks like it's saying 50, but as we saw before, 51 was over there. This is where we're getting a larger angle out. We've gone past 90 degrees. And that's where we use the larger numbers. It's like we've already gone to 90 degrees and then we're adding on above that. So this measurement here would be 130 degrees. And then it would continue on until we end up at a flat line here. And that measurement there is 180 degrees to go all the way around the protractor. So our protractor begins at 0, ends at 180. The idea is if you have a protractor, they're generally clear when you get them, and you can lay them down on your paper, or you just have to find the vertex, and then you can measure out that angle. So let's see how this works out. If we knew the angle measurement that we wanted to use, and I have some clear protractors on top of the paper here, but what we can see is our vertex here, and then we have our starting line mapped out for us for each of these scenarios. So that's starting at 0, and this is how I would line up my protractor. I'd get that little kind of cross there right over the vertex. And then what I would do is think about, I'm starting here at 0, I got 10, 20, 30, and then I want 35 degrees. So then I just go 5 more, and that means this angle right here is 35 degrees, which is exactly what we want there. For 90 degrees, similar setup there. So we have our start at 0 and then measure around until we hit 90, which would be like that. Now, you'll notice some notation I've been using here when we show measurements, like in this first one. I kind of drew this little arch here, and then you could label the number next to it. We can do that with any angle measurements. With 90 degrees, we do something special. It's kind of a special angle that's going to come up a lot, especially when we talk about triangles. We want a short way of showing that it's 90 degrees. So what you'll see with 90-degree angles is just like a little box. It's part of a square there. And then they usually don't write the number next to it, just seeing that symbol there. So if you see this for an angle, that automatically means 90 degrees. So if I was drawing a picture, I would just draw it like that, and I wouldn't write 90 degrees out because it's implied by the symbol. All right, 120 degrees down here. So here we are at 0, and then I'm going to grab my line. So if I'm going off to the right here, there's 0, 10, 20, 90, and then to get 120, we need to go on to the other side of our protractor there. So for this one, this angle measurement here is 120 degrees. And then 180 degrees is a special one where it's going to look like just a flat line. You do have this vertex kind of separating the line up, but so we start at 0 and then we'd be counting all the way around till we get to 180 on that other side. So this angle right here seems can sometimes feel uncomfortable to draw that one because it just looks like a straight line, but it is a measurement of 180 degrees. So that's for if we know the angle measurement and wanted to measure it out, that's how they'll show up. Now we're seeing some special angles here, and each of these could be described a different way. This first one, the 35-degree angle, a term we would use for that is acute. And what you might be seeing with this protractor is there's kind of this cutting point, especially the 90 degrees is kind of the cutting point of having these smaller angles versus larger angles. So when we have these smaller angles, we call them acute. So on this next page, I'm just going to write a definition for you over here. It's that an acute angle is an angle less than 90 degrees. So if I asked you to draw an acute angle, you'd need some sort of starting line and a vertex. And then from there, if I wanted an acute angle, so you can imagine, okay, if here's 90 degrees, then it can just be any spot below that. Anywhere in there would make an acute angle. Let's say it looks something like this. That is a great acute angle there. All right, our next one's a right angle, and that's what we use for 90-degree angles. We say it's a right angle, and when we get to triangles, we'll talk about right triangles. It's having that angle measurement of exactly 90 degrees. So, an angle exactly 90 degrees. So with that, we just need a straight line to start with and a vertex. And then if we had our protractor, we just want to measure to that 90 degrees. I'll draw this as best I can. But then if your drawing isn't quite great like mine, if you just throw in that symbol, then we know it's exactly 90 degrees. All right. And then this 120 degree one, this would be an obtuse angle. So that's an angle that is more than 90 degrees. So if I had to draw an obtuse angle, I'd get my vertex, get my first kind of starting line going, and I could imagine, okay, there's 90 degrees. Anything to the left in this case would make an obtuse angle. So then we'd have that large angle there. And then our last one is this special case of 180 degrees, which is a straight angle since it makes a straight line. So with that, it would be an angle exactly 180 degrees. So with that, we would just get our vertex, get our starting line, and then really to draw the next line, it should just be a continuation of that line that you started with, and that would be 180 degrees. So there's some definitions of types of angles that we could see. All right. So what I'm going to have you do is try out angle measurements. Now this activity, if you print out your paper and you have a protractor, you can go ahead and try that out and finding these measurements by hand. But I'm going to assume we all don't have protractors. So let's even just kind of see some properties that come through based on the structure of this. So what I'm going to do is actually give you some of these measurements. This angle that's defined right here, we're going to have that be 30 degrees. And then also for this first picture, I'm just going to throw in this symbol right here. So then we'll know we have this 90-degree angle. And then for the picture to the right-hand side, for that angle that I defined there, if you have a protractor and your paper printed, that should come out to be 45 degrees. So let's talk about how we could solve for these unknown measurements. Specifically in this first picture, I want to find out what is this measurement here. Now when you're working with an image with multiple angles, like the 30 degrees, you give one line, and then if you want a different angle measurement, then you usually go 2 lines. If we had a different angle, you'd start going 3 lines, so you could just kind of layer them. It's like on the picture on the right, I have that 45 degrees, and then I want to look at this other angle measurement and try to find out what that is based on what the picture is showing us. So with this first one, we can think about this kind of larger angle here, that's our 90 degrees. And that 90 degrees has been cut up with this kind of middle line here. It made this smaller angle of 30 degrees, and then we have this larger angle. So what we could do is just with a little simple algebra is if all of that's supposed to be 90 degrees, all we need to do is think about taking out that 30 degrees that we already know. And what that'll leave us with is this 60-degree angle. Now this case here of having these two smaller angles and they're adding up to 90 degrees, this is called complementary. These are complementary angles because they add up to 90 degrees. So it's this special case of having multiple angles. But the key is that at the outside of everything is this 90-degree angle, and it's just been cut up by an extra line. So I could draw a line here, or there, 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 there. No matter where I draw that line, I'll have complementary angles because they're both part of this larger 90 degrees. Now this picture on the right-hand side, kind of a similar idea, but in this kind of larger scale, is that we have this straight line that they're adding up to, meaning they're adding up to a straight angle, which means overall we have this 180 degrees. We can see 45 degrees of that has been taken up, and we just want to figure out what's left over. So with this, what we would do for calculation is take that 180 degrees, take out the 45, and that should leave us with this measurement of 135 degrees. And also a good thing to double check is like that picture looks like an obtuse angle. Make sure in terms of calculation, we are getting an obtuse angle out. If it looks acute, it should be below 90. If it looks obtuse, it should be over 90. This right here is supplementary angles. So it's when we have angles that add up to 180 degrees. So with this, it's the idea in terms of larger scale. We have a straight angle, some vertex, but then we have this other line coming through, and no matter where it's landing, it's just that those two angles are always adding up to 180 degrees. So we can use that property to solve for unknown ones. All right, so that's complementary and supplementary angles there. Now, what I want to talk about are some extra properties that come through with angles. And again, if you have a protractor, it can be a nice activity to practice that measurement if you haven't used it before. But again, I'll assume you don't have one, and I'll just give you some angle measurements here. This angle right here on the picture would be 128 degrees, and this angle measurement over here should be about 52 degrees. Now, if you do this by hand, you might have a slight difference. That's a theme among measurement with protractors and rulers. When you're trying to get specific with measurements, we might all get slightly different answers just based on human error, but it should be close by to those two numbers. Now, something that I want us to see, if I kind of zoom into just the intersections up here, I could keep measuring with a protractor and getting values out, but what would happen is you would notice a theme start to occur. Like if I went to get this angle measurement right here, it should be exactly the same. And if I measure over here, exactly the same as over there. This property here is the property of vertical angles, and it happens when you have two lines intersecting with each other. No matter how they're intersecting, it's a little property I want us to get down here. No matter how those two lines intersect with each other, you're going to get these pairs of vertical angles that'll have the same measurements. So if I choose this angle here, and that angle has some measurement, then vertical from it or across the intersection over here, that would have the same measurement. Similarly, if I looked at this angle here, this obtuse angle, whatever measurement that has, if I look across the way, that has the same measurement. So this can be a nice tool, like say we knew the angle measurement over here. Well, you have these supplementary angles, so you could find the blue angle pretty easily using that they add up to 180, and then you could fill in the blanks for the other two following that. So with this property, it can help you solve for a lot more angles just by giving you that single angle. Now, to kind of jump ahead in these definitions, I'm going to go to this definition of parallel lines because it's going to help us get other measurements out from this picture. What we want to notice is that this line KL up here is parallel to this line MN down here. Now parallel means that if I continued those lines on forever and ever and ever and ever, infinitely, they would never intersect with each other. They would keep running, and use the term parallel, and that they'll never intersect. So for definition down here, for parallel lines, it's having two lines that never intersect. Now, in terms of notation, like say I did call this KL, KL, and this one MN. For notation, what I could do is take line KL and line MN, and if I wanted notation to say that they're parallel to each other, you'd use a symbol of basically two vertical parallel lines between the notation there. Another way that two lines can work together is perpendicular lines. And it's when you have two lines that intersect with each other. When they intersect, they make a perfect 90-degree angle. So this would be two lines that intersect at a 90-degree angle. So with this, like say this was KL and this was MN. For notation, it would look pretty similar, but we'd use as a different notation since perpendicular is very different from parallel. And for perpendicular, you would just draw something like that, these two perpendicular lines. So what's important up here is that we have these two parallel lines, and why that's important is because then with how this line IJ is occurring, if we have two lines that are parallel that intersect, it's going to bring through the same angle measurements that we're seeing. So what we would have down here is this angle right here would also be 128 degrees. And then based on that property of vertical angles, this would also be 128 degrees. And then that would force this to be 52 degrees because of our supplementary angles, which means this would have to be 52 degrees based on vertical angles and supplementary angles. So what you can see is when you have this line being intersected by parallel lines, we get all of these pairs and the same angles coming through. That really overall in this whole picture, there's two angle measurements, 128 and 52. So some other properties that come through when we have this scenario is alternate interior angles. So if I draw a picture for some line being intersected by two parallel lines, alternate interior, so the interior part of the picture is in here. So that's going to be the interior of our intersections. And alternate interior means, like say we focus on this angle here, it's that if we go to the other intersection and on the opposite side, that measurement's going to be the same. Similarly, if we were looking at this measurement here, if we go to the other intersection and on the opposite side, that would be the same. So where that's showing up in our picture up above here is if I focus on the inside and I have, say, I'm looking at this 52 degrees, I also have 52 degrees on the opposite side, but in the interior. Same thing with 128, it's the interior and on the right-hand side, which means interior on the left-hand side would have the same measurement. Another way that common angles come through with this, if we have a line being intersected by two parallel lines, alternate exterior angles. So that's where we're focusing on the outside here and the outside. So alternate exterior is, say I'm on the left-hand side up here. If I go to the right-hand side at the exterior, same measurement. If I was on the right-hand side up here, it means the left-hand side down below would be the same. So seeing that in our picture up above here, that would be like looking at this 128 degrees at the top here on the left-hand side on the outside, right-hand side of the outside would be the same. and right-hand side of outside up here, left-hand side of outside there. So at the exterior of the intersections, the opposite sides match up. And then the last piece here is corresponding angles, which for these cases, there are a lot of corresponding angles, but it's basically when you have these two intersections where values occur at the same spot, you kind of look at where they line up, and that would be your corresponding angles. So say I'm on the upper left-hand side here, upper left-hand side, same measurement. Lower left-hand side will be the same as lower left-hand side. Upper right-hand side, same as upper right-hand side. And lower right-hand side, same as lower right-hand side. So we end up with these 4 pairs of corresponding angles. So seeing that show up in our picture up above here, it would be like looking at our 128 in the upper left, 128 in the upper left, 52 in the lower left, upper right, lower right, lower right. So it's just using how they line up with each other, and those measurements will be the same. So there are some definitions in how to measure angles.